Welcome to Lesson 3, Base Layers. We'll be discussing the types of base layers commonly used in fire ecology and management, where to find those base layers, and finish up with talking about geodatabases and how they play into how data is being distributed and managed. There are many different types of base layers. The selection of your base layers depends on the questions you're trying to answer and who will be receiving your output. Certainly, vegetation layers are an important part of mapping and analyzing fires, but other common base layers include ownership, hydrologic units, stand boundaries, roads, and power lines. In the world of GIS, the base layers are considered the inputs, and the final product, be it analysis, results, map, or other, is the output. I'm sure it's no surprise, then, that the quality of base layers is very important if you're wanting to deliver a quality product. When taking a course such as this, it can be easy to assume that good data will just appear when you need it. More often than not, though, you'll need to go and do some serious sleuthing to come up with the pieces that you'll need at the quality you need them. The primary challenge might not be bad base layers, but just not quite right base layers, or not used in the correct way. For example, LANDFIRE data, which will be discussed later in this lesson, has many different versions. If you mistakenly get the wrong version, your analysis will not be accurate. Also, it's important to know what's most commonly used by the group that you'll be delivering your product to. For example, the most common scale for topographic maps used for fire is 1 in 24,000. If you choose 1 in 100,000, then your output will not be as useful. As previously mentioned, finding the right data can be a real challenge for students, layperson, or professional alike. Because of large file sizes, multiple processing styles, and agency access restrictions, amongst other things, it's common to know that the right data exist, but quite another thing to obtain it. Fortunately, this is a known issue, and one thing that's been shown to significantly decrease production and consistency in outputs. Several efforts have been made to make quality data more consistently available. This slide shows several locations where GIS data is available to the public, but each area that you work in might have additional data locations. We'll look specifically at some of these sources after a discussion on LANDFIRE, which is one of the most common and reliable sources of base layers. The idea for LANDFIRE began in 1999 when the Missoula Fire Sciences Laboratory was asked by the Forest Service to produce a fine-scale, or 30-meter, nationally consistent fire, fuels, and vegetation data that could be used to compute Fire Regime Condition Class, or FRCC. The LANDFIRE program evolved from increased concern about the number, severity, and size of wildfires. In 2000, the President directed the Secretaries of Agriculture and the Interior to recommend how best to respond to severe wildfires, reduce the impact of fires on rural communities, and ensure sufficient firefighting capacity in the future. As a result, Congress directed development of the National Fire Plan, which precipitated LANDFIRE, along with the creation of a national cohesive wildland fire management strategy, or called the Cohesive Strategy, addressing responses to wildfire, restoring and maintaining resilient landscapes, creating fire-adapted communities, all based on a scientific foundation. LANDFIRE is a shared program between the U.S. Department of Agriculture Forest Service and the U.S. Department of Interior Wildland Fire Management Bureaus, under the direction of the Wildland Fire Leadership Council. LANDFIRE produces a comprehensive, consistent, scientifically based suite of spatial layers and databases for the entire United States and territories. In 2001, the General Accounting Office reported, "Federal land management agencies do not have adequate data for making informed decisions and measuring the agency's progress in reducing fuels." In 2002, GAO reported, "Data are not available to better prioritize communities and projects for funding." And, on the basis of our review, LANDFIRE is the only proposed research project so far that appears capable of producing consistent national inventory data for improving the prioritization of fuel projects and communities. LANDFIRE started with the prototype in 2002 and was officially chartered in 2004 by the Wildfire Leadership Council. LANDFIRE provides over 20 national geospatial layers, databases, and ecological models that are available for the U.S. and insular areas. It delivers vegetation, fuel, disturbance, and fire regime geospatial data products for the entire nation, Methods are used on peer-reviewed science from multiple fields. LANDFIRE products are consistent, comprehensive, and standardized, resulting in multiple applications to fire, fuel, and natural resources. Many sources of data were used as inputs in the mapping effort. Ground reference data of existing vegetation, potential vegetation, fuels, and structure were incorporated along with available GIS data of topography, soils, climate, and ecophysical variables. Examples of map deliverables are maps of fire danger, historical fire regimes, fuels, and condition class. The LANDFIRE mapping efforts rely heavily on field reference data describing vegetation composition and structure and wildland fuel. The LANDFIRE reference database comprises data from numerous sources, both government and non-government, and provides training information for LANDFIRE mapping tasks. The LANDFIRE team relies on the user community for access to vegetation or fuel data compiled for inventory, monitoring, mapping, research, or similar purposes. You need not provide all listed data to make an important contribution to LANDFIRE. Subsets of these or similar field data are welcome and appreciated. The only requirement for all records included in the LANDFIRE reference database is a georeference for each sampling point, preferably as determined with a global positioning system device in the field. If you have georeferenced plot data that meet the LANDFIRE reference database's needs, or know of a possible data source, please visit the website for information about data sharing. The LANDFIRE team established an operations and maintenance strategy for updating data products, as directed in the LANDFIRE executive chapter. An update program is vital to support the full spectrum of fire management and natural resource management programs with timely and quality products to reflect recent changes in landscape conditions. For this transition from LANDFIRE project to LANDFIRE program, direction from leadership and feedback from users will inform selected updates to the LANDFIRE data products. These updates will reflect landscape disturbances and other vegetation changes. The strategy for updating the data set was developed and continues to receive input from interagency fire projects that depend upon LANDFIRE products, including the Fire Program Analysis and the Wildland Fire Decision Support System projects. Updates are released every 2 to 4 years and take 2 to 4 years to complete. When using LANDFIRE data, it's very important to consider the year you're working with. For example, if you're trying to replicate the fire behavior for a fire that occurred in 2011, getting the 2012 data would mean that the vegetation is corrected for post-fire conditions and would not be very useful to you. Disturbance products are developed to help inform updates to LANDFIRE data to reflect change on the landscape caused by management activities and natural disturbance. They are a compilation of data from Landsat satellite imagery, burned area reflectance classification, or BARC, rapid assessment of vegetation condition after wildfire, or ravage, monitoring trends in burn severity, or MTBS, LANDFIRE refresh events, user contributed data, and other ancillary data. LANDFIRE fuel data describe the composition and characteristics of surface and canopy fuel. LANDFIRE fuel products provide consistent fuel data to support fire planning, analysis, and budgeting to evaluate the fire management alternatives and supplement strategic and tactical planning for fire operations. Vegetation is mapped using predictive landscape models based on extensive field reference data, satellite imagery, and biophysical gradient layers using classification and regression trees. LANDFIRE uses vegetation products to create fuel and fire regime data. Most vegetation products use NatureServe's ecological systems classification, meeting the requirement that map units be identifiable, scalable, and modelable. The NatureServe Explorer provides descriptions for each ecological system, including species, description, and classification information. Historical fire regimes, intervals, and vegetation conditions are mapped using the Vegetation Dynamics Development Tool, or VDDT. These data support fire and landscape management planning goals in the National Cohesive Wildland Fire Management Strategy, the Federal Wildland Fire Management Policy, and the Healthy Forest Restoration Act. The elevation derivatives for the National Application, eDNA, was completed by a consortium of participants, including the U.S. DOI Geological Survey for Earth Resources Observation and Science, the USGS National Mapping Division, the USGS Water Resources Division, the National Severe Storms Laboratory, and the Environmental Protection Agency. LANDFIRE delivers 3 eDNA layers: aspect, elevation, and slope, and these serve as inputs to the landscape file to be used in models to predict the behavior and effects of wildfire. At this time, there are several locations where you can go to access LANDFIRE data. On landfire.gov, you can manually select your area of interest, download zip files for each separate layer, and then open them in your program of choice. The LANDFIRE Data Access Tool, or LFDAT, is an ARC toolbar designed to streamline this process by allowing for a more streamlined way to select your desired area. Individual layers still need to be downloaded and unzipped before use. The version of LANDFIRE determines how current the data is. IFTDIS, or Integrated Fuel Treatment Decision Support System, is a web-based software and data integration framework that organizes previously existing and newly developed fire and fuel software applications to make fuels treatment planning and analysis more efficient and effective. IFTDIS requires a login, which can be easily obtained. Getting access to LANDFIRE data is very simple, but again, the current version of LANDFIRE data is not yet available in IFTDIS. WFDIS, or the Wildland Fire Decision Support System, assists fire managers and analysts in making strategic and tactical decisions for fire incidents. It has replaced the WFSA and WFIP and LTIP processes with a single process that is easier to use, more intuitive, linear, scalable, and progressively responsive to changing fire complexity. This system can only be accessed by agency employees, but does integrate LANDFIRE data. The landscape, or LCP file, is used by wildland fire behavior and fire effects simulation models, such as FlamMap and Farsight. These pieces can either be downloaded individually from LANDFIRE, or an LCP file can be downloaded. There are various tools, including LFDAT and ArcFuels, that are able to take the individual pieces and form them into an LCP file. In the next several slides, you'll learn about some of the more common locations for some of the more commonly needed base layers. Again, there are likely many other locations for this information, and often the best source of base layers is a local source to maintain consistency in the final products, unless you find something better, of course. The NIF-CFTP site is a great place for recent fire perimeter data, including IR acquisitions. The site can be a little cryptic, and data quality is not consistent, since it's open source. This site is used by GIS specialists to download IR flight information for map creation and then upload completed products. If you're willing to put a little extra time into sifting through data and verifying its accuracy, then this is a great place to get data that's not available other places. A more historic record of fire perimeters for Idaho and western Montana can be found on the U.S. Forest Service Data Product Information page. USGS offers a site where you can download a variety of quadrangles across the U.S. Inside Idaho is a great source for quadrangles, as well as other layers for the state of Idaho. MODIS fire detection data is available by points and images. Although the product is very broad scale, 1 kilometer by 1 kilometer, it's a very useful tool for large-scale fire monitoring and analysis, and can be a valuable tool in locating the active portions of a fire. There are also many research possibilities with MODIS data. The National Agricultural Imagery Program, or NAEP, acquires aerial imagery during the agricultural growing seasons in the continental U.S. A primary goal of the NAEP program is to make digital orthophotography available to governmental agencies and the public within a year of acquisition. Immediate post-burn severity maps for large fires can be obtained from a Remote Sensing Application Center, or RSAC. MTBS also has a post-fire data available and includes a burn severity map produced roughly a year after the fire. Because of its mission, MTBS contains a more complete record of burn severities. Both products contain a final fire perimeter. In Lesson 7, you will learn more about this data product and its uses. Due to the importance of quality base layers, lack of availability or dependence on the online environment For downloads, many incident command teams, GIS specialists, and some fire modules have been acquiring pre-assembled data drives. These are terabyte drives that are sent to a supplier and then returned with updated and organized base layer information and folder structures to assist in fire operations. This seems to be a reliable way to ensure that you have the data that you will need to map a fire. Unfortunately, at this time, such data drives, specifically the topo maps, are only available within the agencies. There are many other types of base layers that you might need to acquire depending on the scope of your project. Some of this information, like cultural resources, might be sensitive information and only available to those with proper access. Others, like ownership, power lines, and structures, may change on a more frequent basis and need to be ground verified if, for example, you're working on a map to where structure protection would need to be implemented. The moral of the story is that there is a large amount of base layer information publicly available, but that anything you obtain will have to be quality checked. Layers that you're not able to find on your own will need to be obtained from local resources. As you can see, there's a lot of data that you have the potential to work with. How can you possibly keep it organized? Esri's solution to this problem is the Geodatabase. In order to understand what a geodatabase is, you have to first understand what we are using currently. So far in this class, we've only been working with individual shapefiles. Each of these files is independent and can be pieced together in various combinations. There's no relationship between shapefiles or grids. With the current system, not only is it hard to keep the files in a project organized, but it's easy to have each independent shapefile breaking the rules, like a unit perimeter crossing a road, because there's no set rules defining what can and can't happen. The Geodatabase is a more robust and extendable data model compared to shapefiles and coverages. While shapefiles and coverages are outstanding GIS data storage formats, they do not take advantage of the latest data storage technologies. The Geodatabase is designed to make full use of the capabilities of ArcGIS Desktop and ArcGIS Server. The Geodatabase is not just another spatial data format that can be used by ArcGIS. It is an integral part of the ArcGIS system. Geodatabases are the way of the future. They are meant to replace the shapefile system and will in the next couple of years. So what will happen to all of your shapefiles? The equivalent of a shapefile in the Geodatabase is the feature class or feature data class. This is the individual layer. The difference is that this feature class is part of a larger umbrella of organization. It could be in a geodatabase directly, or in one more level of organization called a feature dataset. Take a moment to pause this presentation and look at the comparison between GIS data and geodatabase datasets. Also, look at the figure showing the structure of the geodatabase. What are the advantages of storing data in a geodatabase? 1. All data for a certain area can be stored in one common database. For example, all fire perimeters on the Savoy Bitterroot Wilderness can be stored in one geodatabase. 2. Simplified data storage and maintenance. 3. Multiple users can access the database at the same time, only for multi-user geodatabases. 4. The user can set up intelligent rules and regulations for how the data features within the geodatabase may interact. For example, fire perimeters in a fire atlas are allowed to overlap. Geodatabases come in 3 flavors: the personal geodatabase, the file geodatabase, and the multi-user geodatabase. A personal geodatabase is stored in a Microsoft Access database with a size limit of 2 gigabytes. The newest version and most often used, for our purposes, is the file geodatabase. A multi-user geodatabase is stored in database programs, such as Oracle and DB2, and can handle much larger datasets. The video linked to at the end of this presentation has a very good description on these different types of geodatabases. Another way to describe a geodatabase is that it's an alternative way to store GIS information in one large file. The file can contain multiple point, polygon, and/or polyline layers. Esri is pushing the geodatabase idea because it's a cleaner way of organizing data rather than having multiple shapefiles in multiple folders. With the advent of the geodatabase will come functionality that shapefiles do not have, such as z-axis that could be used in Arc Pro to, say, show tree height over time. So to sum up, a geodatabase is the future of the shapefile and something that you will see frequently when working in large amounts of data, especially in fire ecology and management. If you're still a little confused about what a geodatabase is, don't worry. It's a complicated idea that can really only be understood after using them. So you'll get some experience with geodatabases in this class, and it may then be a good idea to go back and review this material to see what else you pick up. There's also a lot of information available on the web. The link below is an introduction to geodatabases, and there are other related videos that will teach you more. You will now continue on to Lab 3, where you will be gathering and organizing the base layers for future labs. Remember to start thinking about the data that you might need for your final project. Will you be able to find everything you need on publicly available sites? If not, it might be a good idea to start asking around so that you can be sure to have something to work with when the time comes to submit your proposal.